Children, in this video we are going to learn about electronic configuration of atoms. What is meant by electronic configuration? It represents the distribution of electrons into various orbitals of an atom. Distribution of electrons into various orbitals. What are the various orbitals? S, P, D, F. S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, F can hold 14 electrons. So by following alpha principle means what? Electrons filled in the increasing order of energy level. Next, Pauli's exclusion principle. No two electrons in an atom can have all the 4 quantum numbers equal. What is Hund's rule? Electron pairing is impossible until the orbitals are singly filled. Based upon these rules, the electronic configuration is written as N, L, X. N represents principal quantum number. L represents the azimuthal quantum number, that is orbital designation of the orbital. If for the s orbital L is equal to 0, for the p orbital L is equal to 1, for the d orbital L is equal to 2, for the f orbital L is equal to 3. X, what X represents? X represents the number of electron present in that orbital. So consider, now we are going to learn some of the example. Consider hydrogen atom, which has only one electron. It is the first element of the periodic table, having atomic number 1. So it occupies the lowest energy level, that is according to alpha principle. N is equal to 1, principal quantum number, having only one electron, that is L is equal to S. Then X is equal to 1 number of electron. So the electronic configuration is written as 1s1. 1s1. L is the orbital. N is the principal quantum number. X is the number of electrons. So 1s1. So that orbital diagram, how written? Orbital diagram 1s1, 1 electron. So now we can see some of the examples. Hydrogen having 1 electron. So the configuration is 1s1. Orbital diagram. This is the orbital diagram 1s1. 1s1. Next, helium, atomic number 2, configuration 1s2. So orbital diagram, 2 electrons having opposite spins 1, 2. 1s. Next, lithium, atomic number 3, configuration 1s2, 2s1. So 1s, orbital diagram 1s, 2s. 1s2, 2 electrons having opposite spin, 2s having only 1 electron. Next, beryllium, atomic number 4, configuration 1s2, 2s2. So 1s, 2 electrons, and 2s also 2 electrons having opposite spin. Next, boron, atomic number 5, configuration 1s2, 2s2, 2p1. After filling S, it goes for P. So already I told S can hold 2 electron, P can hold 6, D can hold 10, F can hold 14 electrons. So after filling 1s, 2s, it goes for 1p. So orbital diagram 1s, 2 electron, orbital diagram 2s, 2 electron. When goes for P, P having 3 orientation. So 3 boxes having 2p, that is 2px, 2py, 2pz, having only 1 electron. So it occupies in the x orbit. Next, carbon 6, 1s2, 2s2, 2p2, orbital diagram 1s, 2 electron, 2s, 2 electron, 2p having 3 orientation, 2px, y, z, x, y occupying 1 electron, it is kept vacant. Next, nitrogen 7, 1s2, 2s2, 2p3, 1s having 2 electron, 2s having 2 electron, 2p, 2px, 2py, 2pz having 1 electron. Now oxygen 8 atomic number 1s2, 2s2, 2p4. 1s orbital diagram 1s 2 electron, orbital diagram 2s 2 electron, 2p 2p 4 electrons having 1 2 3, then starts pairing according to Hund's rule. Hund's rule, no two electron pairing occurs until the orbitals are singly filled. After singly filling, then starts pairing oxygen. The next for fluorine, atomic number 9, 1s2, 2s2, 2p5. So 1s 2 electron, 2s 2 electron, 2p xyz 1 2 3 4 5. Then next neon 10, 1s2, 2s2, 2p6. So 1s2 electron, 2s2 electron, 2p3 orientation 1 2 3 4 5 6, 2p. So fully filled. Now here some variations occurs in copper and chromium. For example, copper atomic number 29, chromium we can see first chromium atomic number 24. Expected configuration, expected is 24, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, 3d4. This is the expected configuration. But actual, what is the actual configuration means, here this 4s electron gives 1 electron to 3d, so 3d becoming 5. Why it is becoming 5? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Why? What is the reason for this 4s1, 3d5? To make it stable. 3d5 means half-filled configuration. Half-filled configuration is more stable when compared to partially filled configuration. Similarly, for example, copper atomic number 29. Expected configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is the expected configuration. So what is the actual configuration means? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. To make it fully filled, 4s electron gives 1 electron to 3d to make it stable. So this is the actual configuration for chromium and copper given in the periodic table. This is a very important question. Reason means the fully filled orbitals and half-filled orbitals have some extra stability. Half-filled means P3, fully filled means P6, half-filled means D5, fully filled means D10. Then F means F7, F14. These are more stable than P2, P5, D4, D9, F6, F13. Due to the stability, one of the 4s electron occupies the 3d orbital in chromium and copper to attain the half-filled and completely filled configurations. So it is clearly given in the book to write the configuration.